So let's talk about arithmetic sequences. If you just want to skip to the part where I work out some problems, there's a timestamp in the description. This is one of the two sequence types that you're going to study in an Algebra 1 or more likely an Algebra 2 course. The other sequence is a geometric sequence, which I have a separate video on. Right? An arithmetic sequence is typically the sequence you look at first, and because of that, this video will go over what a sequence is, what certain notation is, and what certain terms mean. My video on geometric sequences is more straight to the point, right? Assuming you already know certain terms, what a sequence is, it just gets right to it. All right, so let's just start. Simply put, a sequence is a list of numbers with a pattern. An arithmetic sequence is a type of sequence with a specific pattern or rule. It's an arithmetic rule. So in an arithmetic sequence, in order to get the next number, you have to add the previous number in the sequence by a specific number called a common difference. Now, here are a few examples of an arithmetic sequence, right? Something like this. Perhaps we have the first being 1, and then 4, and then 7, and then 10, and let's say this goes on forever, right? A sequence would continue on forever. So what makes this an arithmetic sequence? Well, let's look at how these numbers are changing, right? What is the difference between this 1 and 4? It looks like I had to add 3 to get to it. What about this 4 and 7? I had to add 3 to get to it. 7, 10, I had to add 3 to get to it. So when you have an arithmetic sequence, it's constantly, you're taking this common difference. This is what the common difference would actually be, and you're continuously adding on to it, right? Sequences don't have to start at 1, and they definitely don't also have to go up in value. They could decrease, right? You could have a sequence that maybe starts at, let's say 11, and it decreases by 5 every time, right? So let's say this could be 11, then 6, then 1, then -4, then -9, and so on, right? What is the common difference, right? I said before that you're adding a specific number on, and here I said we're decreasing, I'm taking away. Well, that's the same thing as just adding a -5, right? -5 would actually be the common difference. Okay, so those are a couple examples of sequences. Right, so one thing that confuses people in the beginning is this specific notation here that I do want to just quickly define. A sub n. Okay, it's new to people just starting sequences. Sometimes I've seen people even try to multiply this n part to like an a or something like that and try to divide with it, do some arithmetic with it. This is basically a subscript, okay? This acts as a label for this a of n. So if I write a of 1, that means what is the first term in the sequence. In this sequence up here, a of 1 would be equal to 1. In this sequence here, a of 1 is equal to 11. If I were to write a sub 5, that's the fifth term. Here, the fifth term would actually be, if I went further, would be 13. Here, the fifth term is -9. And something we're going to need in a little bit is a sub n plus 1. So when I talk about the nth term in a sequence, that's kind of like a variable for that label, right? Any number can go in there. So if I have an equation that uses a sub n plus 1, once I pick a number for n, let's say I pick 5 for n, a sub n plus 1 would be a sub 6. Okay, and that'll become more clear with some future examples. Right, now that we know what an arithmetic sequence is, we want to know how to describe a specific type of sequence. It'd be impossible to actually list out every number in an arithmetic sequence. They go on forever. So we're going to actually use a formula to describe an arithmetic sequence. So it helps us basically describe the pattern that's happening. There are two styles of formula that you're going to need to be able to deal with: explicit and recursive. All right, so let's start out with the easier of the two. I'm going to make just a quick little chart. All right, so here's my little box. I'm going to write my explicit formula here and recursive formula here. Now, explicit to me is the easier of the two, and it's the one that I suggest you go to if a question doesn't specify what kind of sequence to use. All right, so here's the explicit formula. And what this gets you is any specific term. So if you're looking for the 5th term, 8th term, 28th term, 157th term, this formula gets you that term. So it is a sub n, where n is, you could put any number there. So if you're looking for the 5th term, you'd put 5 in for n. If you're looking for the 8th term, you put 8 in for n. That's equal to a sub 1, the first term, plus d, which is that common difference, which in this case here was -5. In this case here was +3. Then in parentheses, it's multiplied by n minus 1. Okay, and that'll get you any term in the sequence. Now, this again, it's just a simple formula. You just have to remember what each of these three components are. Now let's look at the recursive formula. This can be a bit more confusing because there are two parts to them, something called the base case and the actual formula. All right, so recursion basically means I'm describing something based off the previous thing. Okay, and this is where that a sub n plus 1 kind of works. All right, so a base case is your starting point. All recursive formulas need a place to start from. So in the beginning, they'll always tell you what your first term is. They'll say a sub 1 is equal to, whatever the first term is. Then they'll say, I have this particular formula. A sub n is equal to a sub n minus 1 plus the difference, the common difference. Now, what this means is that, okay, so I'm looking for the 5th term. All that means is I take the 4th term and I add the common difference to it, right? If n is 5, n minus 1 is 4, right? If I'm looking for the 20th term, I take the 19th term and add the common difference to it. Now, in my opinion, as far as your class goes, this formula gives you less to work with. And typically, if you're looking for maybe the 20th term and you're given the recursive formula, it might even be easier to change it and derive the explicit formula and then look for the 20th term using that. Now, the last thing I need to talk about is the formula for summation, right? You could get problems that say, hey, I want you to add up the first 20 terms. I want you to add up the 80th term all the way to the 122nd term. Now, if something says I'll add up the first 20 terms, sure, you can just make the list and add them up in your calculator or something like that. However, if they give you 100 terms or 1,000 terms, you want to be able to do that quickly. And here's the formula to use. All right. The summation of the first n terms, so 1 up to n, right, first term up to the nth term, is equal to n times a of 1 plus a of n, right, first term plus nth term, all divided by 2. Okay? Now, if you remember these three formulas, that gets you through every type of question involving a arithmetic sequence. Now, there's one more thing I want to go into. It's called the summation. It's called summation notation. It's sigma notation. This is something some classes will go into and some classes won't. So I won't spend too much time on this. I won't explain it super in depth. But it's basically this symbol. You might have seen it on a graphing calculator. Okay? Something like this would be, say I had some formula 3n plus 8. Okay? And then here would go two numbers. N equals 1 up to 8. Now, this is something called a series, and I won't go too much into that, but this and this are basically doing the same thing, right? This is a more general form of doing a sum, okay? When you do the sum of an arithmetic sequence, it's basically, hey, I have the first term, like I want the first term, I want the nth term, let's say it is the 8th term, and I have the rule, right, which is a formula. I put that into this formula, and I get the sum of all those terms. This is doing the same thing. Down here is where your initial term goes. I want to find the first term, the sum of the first term up to the 8th term. Your final term goes up there. And how, like, what is it that you exactly want to sum? Well, I'm basing it off this rule, right? So 3n plus 8 is the rule that I'm using. So when n equals 1, this whole thing equals 3 times 1 plus 8 is 11. When n equals 2, 3 times 2 is 6 plus 8 equals 14. When n equals 3, it's 9 plus 8 equals 17. And here you would get the first, 8 terms. You'd do that all the way up to the number 8 and sum those up. Okay, so sometimes you might get this question, right? Like sum up these terms as this, where they give you this symbol, they say 1 to 8, they give you this, and they say compute the sum, compute this, series. That's what that means, all right? I'm not going to go too much into it because, like I said, if your class does go into it, it won't be heavy into using this notation because this can get very complicated. You're definitely going to see it in a calculus or pre-calculus class. But for now, let's look at some practice problems that you might get. All right, so for this first type of problem, we got something that you're going to see quite often when dealing with sequences. So the question reads, write the rule/formula for the nth term in the following arithmetic sequence. And then I've also added, find the sum of the first 20 terms in the sequence. I'll do that with the first couple of questions just because summation is something easy to add on to the end of it. Okay, so let's focus on the first part for now. Write the rule for the nth term in the following arithmetic sequence. And here's the sequence they give you. All they do is they tell you it's an arithmetic sequence, which is something they should tell you because you wouldn't know that just off a finite number of terms. But, they might not. And then from the first few terms, we need to be able to write the rule or formula. That would be either the explicit or recursive. They might specify which one to use. If they don't, it's up to you. But for the purposes of this example, I'll do both, right? You should know how to do both. So let's look at the explicit form. What do we need for the explicit form? A of n is going to stay A of n, right? Because that's what we're looking for. We're trying to write a formula for the nth term of the sequence. So the information we need is A sub 1, the first term, and the common difference. So let's look for those. Now the first term is already given to us. We have it as -2. So easy. I'm just going to the side or write my information. That's something you should kind of get used to doing in a lot of math and science courses. It helps you keep track, trust me. So a sub 1 is equal to -2. Now let's find the common difference. That's easy enough, right? Let's see what the spacing is between each term. Here we got a +4. Here's a +4. And here is a +4. So I'd be kind of it would be kind of a good idea to just say the common difference is 4. You'd be justified in saying that the common difference is equal to 4. Now we have the two pieces of information we need. Let's put it into the formula. So a sub n is equal to n plus 1, or sorry, a sub 1, which is -2, plus the common difference 4 times n minus 1. Okay? So you could end here, right? This is a perfectly valid solution, and you would get full credit if this were a short response question. However, if you're dealing with a multiple choice question, they could have this in a different form, right? So if you are dealing with that and your answer doesn't match one of the answer choices, don't worry, try doing this. Try actually simplifying this expression. Multiply this 4 out, you get -2 plus 4n minus 4, and then combine, and then you get 4n minus 6. And that's totally another valid way of writing the sequence. Okay, so that's the explicit formula. Now let's look at the recursive formula. What do we need for that? We need a base case, and then we need to just write out this formula. It uses the same information. We need the first term, and we need the difference factor. Okay. Now I know some of you might be thinking, like, why is the recursive formula useful in the first place? It's useful in a lot of different places. Just for the types of questions you might be dealing with, it might not be useful in this circumstance. But trust me, it is useful. So let's say we already have the things we need. So the way you would write it is you would write a sub 1 equals -2. And then underneath it, you'd write the actual formula. A sub n is equal to a sub n minus 1 plus the difference factor, which is 4. Okay? So these two are how you would answer this question, depending on whether it's asking for explicit or recursive. However, if it's asking for, or if it doesn't specify, rather, I would just go for recursive. It's the simpler one to use in these cases. Lastly, let's find the sum of the first 20 terms in a sequence. That is going to be using this formula. If they gave you summation notation, they might ask for, like, it would look something like this, right? If you were to write it in summation notation, sum of terms 1 to 20, right? That'd be the first 20 terms. Then they would actually put the formula in here, or you might write it yourself, 4n minus 6. Okay? Sum terms 1 to 20 based off this rule. So now let's use the actual the formula for specifically an arithmetic sequence, right? The reason we use this is because this works in every case, regardless of the style of sequence you have. The summation formula works for arithmetic sequences exclusively. Well, at least this summation formula. There's going to be another one for geometric. So S of 20 is equal to, what is n? Well, n is going to be 20 times a sub 1, which is -2, plus a sub n, the 20th term. So what we need to do is find that out. Easy way to do that is to put in 20 in for n in either one of our equations, either this one up here or this one down here. Okay, I think the second one will be easier for some of you guys. And I'll just use a calculator to quickly get that. And I end up with 74. So 74 goes here. And then I put that all over 2. Now that should be easy enough to compute, right? 74 plus -2 is 72 times 20 is 1,440. And then all divided by 2 gets me 720. So summation of 20 equals 720. Okay, and that's an easy thing to just put in your calculator. I think you guys are working with graphing calculators at this point. All right, so now let's move on to the second problem. All right, so this one is stated slightly different, right? We are not asked to find the rule or formula. We're asked to specifically find what is the 52nd term in the following sequence when we're only given the first, like, 4 terms. All right, so how do we go about doing this? How do we find the 52nd term? We could just count, right? These look like they're changing by, so 2 to 5 is 3, 5 to 8 is 3, 8 to 11 is 3. We could just keep adding 3 till we get there. But it's going to be much easier to actually use our formula. Before we can use it, we actually got to find it. Okay? So 52nd term means we're looking for a sub 52. So how do we find any a sub n? Let's start figuring it out. We need the first term, a of 1, and we need the common difference, d. The first term is 2, given to us. Easy enough. The common difference, what is it changing by? I mentioned it before. It's 3 plus 3 plus 3, right? Just continues like that. So plus 3 is our common difference. Great. Now we just a sub n equals, what is the first term? 2 plus the common difference, which is 3 times n minus 1. Okay, now I'm going to simplify it. Just, it's a habit you might want to get into, just kind of recognizing you can change an equation this way. And then I end up with, after combining like terms, 3n minus 1. Now how do I find the 52nd term? Well, that should be a of 52. And that's equal to 3 times 52 minus 1. And then, after just some plugging into your calculator, or you could do this by hand if you so choose, 3 times 52 gets you 156, minus 1 gets you 155. Okay, so a sub 52 is equal to 155. Okay. Now, I kind of want to change this question a little bit. The second part, find the sum of the first 10 terms. I want to change it to find the sum of the 10th term to the 15th term. Okay. So 10th term to the 15th term. I want to do that because the method will be slightly different, but it's going to use all the stuff we've talked about so far. Okay, because I don't have a formula for the 10th to 15th term. I can do the sum of the first 10 terms. I can do the sum of the first 15, right? But I don't have a formula for 10 to 15. And just to, if anybody's wondering, in sigma notation, what that would look like is the following. You would have sigma, you would start at 10, go all the way to 15, and it would be based off the formula 3n minus 1, or 2 plus 3 times n minus 1. Okay, so how do we do this? Well, it kind of visually works this way. Say we have the first term over here, all the way to the 15th term over here. And the 10th term, I guess, is somewhere right about there. If we sum the first 15 terms, we get all of this bit, right? And then separately, if we sum the first 10 terms, we get this whole bit there. Now, what if we subtract them from each other? Take this and take away this part. What are we left with? The 10th term all the way to the 15th term. And that's exactly what we're going to do. We're going to do two different summation formulas. All right, I'm just going to grab a separate sheet of paper here because I'm going to run out of room. So based off the summation formula, let's first get the first to 15 terms, the first 15. So it's going to be S of 15 equals 15 times the first term, which is 2, plus the 15th term, which we get by putting in 15 into our equation. So 3 times 15 is 45, minus 1 gets us 44. So 44 is the 15th term, all divided by 2. Okay, now 44 plus 2, obviously 46, times 15 is 690, divided by 2 is 345. Now let's get the sum of the first 10 terms. Sum of the first 10, similar stuff. 10 times 2 plus, what is the 10th term? 3 times 10 is 30, minus 1, right? I'm just using this, is 29. 29. And that's all over 2. Okay, so 29 plus 2 is 31, times 10 is 310, divided by 2 is 155. So the 10th term is, the sum of the first 10 terms is 155. So how do we get the sum of the 10th to 15th term? Well, that'd be the sum of the first 15 minus the sum of the first 10, which is equal to 345 minus 155. And that is 190. That would be the answer to that. Okay, that one's a bit complicated, understandable. If there are any questions, you can obviously leave stuff down in the comments, but hopefully that made sense. All right, let's look at the next example. Okay, so here's the third question. You're given the following recursive sequence. You're actually given the recursive formula and asked to find the formula for the explicit form, something that could happen pretty often. The second part of this question states, find the first 5 terms in the sequence, right? Not the sum, but what are the actual terms? Which is a question you could commonly get, you know, it's like, oh, here's the formula, what are the actual terms? Think of it as the opposite of these kind of problems we've been doing. Okay, so first let's find the explicit form. What do we need for the explicit form? Well, that's going to be a sub 1, and we're going to need d. A sub 1 is given, right? It's the base case. Anytime we're doing something recursively, we need a starting point. So it's going to be 3. And the difference is given to us kind of in the formula, right? If you're familiar with the recursive formula, you should know the thing being added to that a sub 1. Ooh, this is written somewhat incorrectly. This should be a sub n, and this should be a sub n minus 1. Anything added to the a sub n minus 1 should just be the difference factor. So our difference factor is 4. And from here, we can just write out our sequence, okay? So a sub 1 is equal to what? A sub n is equal to what? 3 plus 4 times n minus 1. Okay, and then by multiplying out, we know this is equivalent to 3 plus 4n minus 4. And simplifying further, 4n minus 1. Okay, now let's find the first 5 terms in this sequence. So we know the first term is 3. Now for this kind of thing, yeah, sure, we could use the formula, but it's easier just to count. So 3 plus 4 is 7, plus 4 is 11, plus 4 is 15, plus 4 is 19. Those are the first 5 terms in the sequence. All right, simple as that. Now let's go to the last problem. All right, so number 4 has a part A and a part B. I kind of just wanted to do 2 examples of this kind of question. Just because it, in my opinion, is out of any of the things we've done so far, it is kind of the most confusing. And it does come up pretty frequently. It's definitely comes up way more than the summation notation thing ever comes up. All right, so given the following information, and the information we're given is specifically 2 terms in the sequence, right? We know we have a sequence, and the only thing we know is that the 4th term, in this case, is 13, and the 9th term is 28, right? We want to somehow write the explicit terms of the arithmetic sequence. I think I meant to write explicit formula for the arithmetic sequence. Okay. So how do we go about doing that? All right, try to think about it, pause the video, and try to think about how you might want to do this. All right, so let's look at the first one. This we know the 4th term is 13 and the 9th term is 28. So what do we know about an arithmetic sequence? We know that it follows a rule. It's constantly going up or down by the same amount every time. That is actually very similar to the way a linear equation works, right? If you kind of think about this term as coordinate points, right? So say in the previous question, we got these first 5 terms. 3 was the first term, 2 was the second, 7 was the second term, 11 was the third, 15 was the 4th, 19 was the 5th. If you think about these as coordinate points, you would find that it forms a linear equation. We can kind of utilize that similarity to assist us with this, because what do we need? We need the first term, which is a sub 1, and we need the common difference, d. The information we need is still the same, we're just going to be getting it in kind of a unique way. Okay, so if you were to plot these coordinate points here, you would find out that the common difference is 4, right? Or sorry, not find out the common, so we know the common difference is 4. You'd find out the slope is actually 4. The slope correlates to the common difference when you're kind of talking about the similarities between a linear equation and an arithmetic sequence. Okay, there's a lot of correlation there. So let's see if we can find the common difference by treating this like coordinate points. Okay? The actual terms will be the x values, and the other things, the actual, what the term is, will be the y values. So, treating this like a linear equation, the way I'm going to do this is, okay, a of n1 minus a of n2 over n1 minus n2. So in this case, I'll do 28 minus 13 over 9 minus 4. Okay, so 28 minus 13, what does that equal? That is going to be equal to 15. 9 minus 4 is equal to 5. 15 over 5 gets me 3. 3 ends up being my common difference. Okay? And anytime I pick 2 points on a line and set it equal to the slope, those things should work out. We're going to use that property to get the a of one term. Okay? So, for example, a of 9, right? Or actually, we'll do a of 4. That looks like it'll be an easier thing to use. A of 4 minus a of 1 over 4 minus 1 should equal 3, right? The slope should be the same, like for any 2 points that I choose. So let's fill this in. A of 4 is 13, so 13 minus A of 1 over 4 minus 1 is equal to 3. And all we do is solve for the A of 1 term. 4 minus 1 is itself 3. And then I multiply that over to the other side. I end up with 13 minus A sub 1 is equal to 9. And what is my A of 1 term based off this? It must be 4. Okay, so A of 1 I got equal to 4. And just like that, we have the two pieces of information we need. All right, so my final formula, I'm going to write it to the side, kind of here, just to save on paper, is going to be simply A sub n is equal to 4 plus 3 times n minus 1. And you could obviously easily just kind of simplify this. 4 plus 3n minus 3. And the alternate form of this formula would be, let's see, 3n plus 1. Okay, now let's look at the second question, right? So we have A of 21 equaling negative 42, and A of 78 equaling 189. All right, bigger numbers, same concept. Shouldn't be too difficult. So first, we're going to need, well, what we're looking for is our A of 1 term and our common difference. The first thing we're going to do is get our common difference. All right, I'm going to kind of go through this a little more straightforward. So the way we get our common difference is set up that, modified slope formula. How do we do that? Okay, it's going to be 186, and negative 42 will act as my values in the numerator. So 186 minus negative 42 over, they have to correspond, so 186 corresponds to the 78, and negative 42 corresponds to the 21, okay? And to compute this, right, this is a bit too much for me to do in my head, so I'm just going to use a calculator. So 186 minus negative 42 is 228 over 78 minus 21, that one's much easier. That one is 57. And then I divide those. I really hope I picked numbers that make sense. Oh, sweet. It simplifies to 4. I thought I'd have to deal with decimal, but I don't. It's great. So my common difference is 4. Second step, let's get my A of 1 term. I picked the one that I think is easiest to work with. I always prefer working with a smaller one. Easier numbers. So it's going to be negative 42 minus A sub 1 over 21 minus 1. And then that should be equal to 4. So solving for A sub 1, I should get the following, right? 21 minus 1 is 20. 20 times 4 is 80. So I get negative 42 is equal to minus A sub 1 is equal to 80. And then I add 42 to both sides. And I get negative A sub 1 is equal to 122. And then I move the negative over to the other side. So A sub 1 is equal to negative 122. Right? Negative 122. Now I can write my formula. I have the pieces I need. So A sub n is equal to negative 122 plus whatever the common difference is, right? Which is 4 times n minus 1. And then, again, just to simplify, right, because you could be encountered with that pretty often, negative 122 plus 4n minus 4. Combining those, I get 4n minus 126. And that would be my final answer. Now, just to do a quick recap, I like to kind of just go over things at the end of videos. What is a sequence? A sequence is just numbers that go on forever based off a certain rule, right? An arithmetic sequence, and kind of a fun fact, or I guess just a fact, it's not really that fun, but arithmetic and arithmetic are written the same way. Why is the pronunciation different? Arithmetic is a noun, right? Arithmetic is a verb. It actually describes what kind of sequence this is, right? What kind of rule you use. And the rule is you're always adding a number over and over. I actually didn't do any examples with negatives, but you could be adding a negative number if you have a sequence that decreases over time, right? So in an arithmetic sequence, you should be familiar with an explicit and recursive definition, formula, or rule. All of those are basically mean the same thing in this context. Explicit formula, a sub n equals a of 1 plus the difference factor times n minus 1. Recursive case, you have two parts. You need the base case, a jumping off point. You always need to say what the first term is. Or at the very least, you might, it's very rare, I've never actually seen this, where they give you some other term. It is possible, but they need to give you a point to work with. Then they give you the recursive formula, which is always in the form a of n equals a of n minus 1 plus the difference factor. Other questions might ask you to sum the first something terms, or sum terms between this and that, right? Here's the summation formula for the first n terms. If they ask for the terms in between two specific things, like this works anytime you're going from 1 up to the 20th term, 40th term, 82nd term, whatever it is. If you're looking for the sum of the terms between two things, like let's say 78 and 39, the way you do that is sum 78, sum of the first 78 terms minus sum of the first 39 terms. Okay, and the last thing that I talked about was the summation notation. This is the Greek letter sigma, right? On top of it, you put that end term. On the bottom, you put the beginning term. So something like this would be used in sigma notation, like this, n equals 38 up to 78. And then whatever rule is governing this summation would go here, the formula. And when you're using summation notation, it's not exclusive to arithmetic sequences. It can be used for any kind of sequence, right? You just got to make sure to put the rule in there. However, for this video, we were only working with arithmetic sequences. Okay? Hopefully that should cover everything about arithmetic sequences. I have another video on geometric sequences, which is the other type of sequence an algebra student will go through. If there are any questions, leave it down in the comments. I'll answer them as quick as possible. If this video helps, hit the like button. Definitely helps me out. And other than that, good luck, guys.